the third question for chapter 1, Electrostatic.
Do you still remember this chapter? Or would you like to go over the chapter summary with me? Then you may check out this video.
So this time the question is about electric potential. Okay, the symbol is V, and also electric potential difference, and the symbol is delta V. Okay, so we have the same case or the same figure as in the question, in the previous question, question number 2. So the question is, so this is the figure. We have point A, point B, Q1, Q2. Okay, the first one is to calculate the potential at point A and point B. So basically point A, potential at point A is contributed by potential from charge number 1 and also charge number 2. Okay, so please remember that when we calculate potential, okay, we need to include the sign convention, the negative sign especially. So now we substitute the equation. Okay, so we have for point A, V1 plus V2. So we may factorize our constant K is equal to Q1 over R from point A to charge number 1 plus Q2 R distance from point A to charge number 2. Okay, we substitute the values. 9 times 10 to 9. Okay, we have 8 for Q1 times 10 to minus 6. The distance is 3 plus negative. Okay, we have to include the negative sign. Minus 6 over 5. And you're supposed to have VA as 1.32 times 10 to 4 volts. Okay, and one more thing is to find VB, so potential at point B. So basically we have the same formula, V1 plus V2, but the difference is at the distance. So it's supposed to be Q1 over R from B to charge 1 plus Q2 is R from B to charge number 2. So that's the difference from finding VA. And again, we substitute the values. 10 to 9. Okay, so 8 times 10 to negative 6 over. So this time our distance is square root. Okay, square root. So basically we want to find here the distance from charge number 1 to point B. So it's supposed to be square root 4 squared plus 2 squared. So it's equal to square root 20. Okay, square root 20 plus negative 6 times 10 to minus 6 over 2. Okay, then you will get negative 1.09 times 10 to 4 volts. Okay, so this is for VA and this is for VB. Okay, now we want to solve the second question, B. Okay, calculate the electric potential difference. So for B, electric potential difference is delta V. So it's equal to, so you may write VB minus VA or VA minus VB. So when we just want to get the magnitude of difference, so it doesn't matter. So it's supposed to be negative if I substitute from the first equation. Negative 1.09 times 10 to 4, negative 1.32 10 to 4, then you're supposed to get negative 2.41 times 10 to 4 volts. Or your answer could be positive 2.41 times 10 to 4 volts.
Do you still remember this chapter? Or would you like to go over the chapter summary with me? Then you may check out this video.